Okay, hi, my name's Gary Taylor, and this is MassTransit Request. You're probably sick of me saying this now, but just in case, this is just an overview of me learning and discovering new features with mass transit and just understanding exactly what it is under the hood. So, this is a walkthrough where I'm demoing and playing about and experimenting and learning as I go. There'll be a masterclass after this once I've got the basic resources done. Now, that doesn't mean that I'm a complete amateur. I kind of know what I'm doing. I've been working with queuing systems and for the past 10, maybe even 15 years. So I've got enough information under my belt to kind of give me a fighting chance to know what I'm doing, or at least to be dangerous. So today we're going to have a look at mass transit requests, and this has been something I've been excited to dive into. So let's dive straight in. If we look at the request page on Mass Transit, we can see that this is where we're able to send off a message to the queue. Some consumer will accept that message, as we've done in previous videos. And the difference is that we can actually return data back to the calling producer. And the producer is locked, waiting for that call to come back. However, because we're using the task, well, I say we, Mass Transit, are using the task parallelizing libraries and C# functionality, that means we can use the beloved async and AO8 keywords to make sure that our application remains responsive and it isn't blocking. So we can write really good, I'm going to say multi-threading, but you know what I mean, asynchronous code that allows us to communicate over different services. Now, I'll get into it at the end about why we shouldn't. Um, the thing to note is that when we're doing this, there is going to be some latency introduced. You know, you're going to have to wait for that response to come back. You are going to be making a request that's holding, so that task is on hold whilst it's waiting for that request to come back. And you're making a request across the wire, which is always going to be less efficient than it running within that native executable. But the benefits come from it being distributed, from being able to call it from multiple places without the overhead of having an API set up and having to secure that API, configure that API, get a Swagger documentation over the front of it, load balance it, and all the other things that you need to do when you're fleshing out a endpoint API system. And if that system doesn't ever need to be public, you know, that it's never going to be released on the web, it is an internally private service, then why should it be an API? We could just call a consumer, get it to do some work and return that back. So here we have a couple of things. Let's get started then, shall we? Let's create a new project. So I've got Visual Studio open, yeah, code open, should say. Let's create a new .NET Core application. Let's do it a console. Jeez. And we want to call this Mass Transit Request. Let's dive in and let's open this up in the main project. Okie dokie, and let's copy my help file. PowerShell, I changed that. Okie dokie. So I just have a README file that includes all the goodness. So what I'm going to do is I'm going to get Mass Transit installed. I need Mass Transit. I'm definitely going to need RabbitMQ. Awesome. So now I've got the basics installed there. Let's just do a build. Just to make sure I've not messed up this. I always do a build just before I start adding things on, because if the original build doesn't even work, I could waste a lot of time. So let's dive over. What I'm going to do is have a look at the console app, which is here, just to get the basics up and running. If I have a look, we've got some message contracts and we've got a request consumer. Okay, so this is taking a consumer, it's going to consume a message which is an iOrder repository, and we're going to respond. Now this is the golden egg. This is the, oh, sorry, where was it? Sorry about that, my keyboard went crazy. This here is the golden egg. This consumes the message, but actually responds back with some data. So the order status result comes back from check order status. So we could say, you know what, here's an order ID. Can you tell me more information about it? And it can throw an exception and say that, you know, we didn't find the order. Or it can go to the database. In between here, we could write some code that goes to the database and checks that order, and then comes back with the information about that particular order, which, you know, then can be used within the remainder of that code that's called it. In other words, a producer will send a message saying, you know, check order status, and it will get back order status result. So that's the consumer. And what have we got here? We're configuring, we need dependency injection apparently. This is going to be a service configuration. But if we have a look, if we do a console app, we can actually set it up without dependency injection because we can just create the factory ourselves. But here they're recommending that we use the service, which would then need a config service. And I want this to be a console app, so I kind of already gone down the wrong route. I created a new console app and the code's now starting talking about it being a web app. So I've started, so I'll finish. This is bread and butter stuff, adding a consumer, and then that's unusual, that's different. Add request client, check order status, and this is just within the main service. So when we're adding MassTransit, we can say add request, and we know that we're going to get a request of that type. If it was a hosted service, then we could add MassTransit hosted service, which would start the bus, which has been pretty much different. There's like 5 different ways of doing this. Right, we've now got the controller, because obviously this is talking about like a API website. Dependency injected that request. We get it back. So I've already created a rod for my own back here because I've just created a console app. I'm not going to be able to use that because it's services, unless I put dependency injection in, of course, which I probably will. And then we need the iClient request. And what do we do? So that's a client, it's going to get the response. So that's like a producer, but just have note that it's very different than the producers we've been working with. So this is just a call to get a response. So although it does use MassTransit, it does use queues. I think it uses like a temporary queue, if I remember. This data is going to come back over that channel, and instead of it being like a send or a publish, we've got this client which understands that it's a request client. It knows what data it's going to send, and then it knows what data it's going to get back. So that object there is going to be of that type. Okay, let's see if I can do it in a console app. It just means I have to understand all the configuration. So it might take a little bit longer than I would really like. So let's create the bus. We need tasks. Public static. Public static async. Return void. Okay. Start the bus. Need to start the bus. In fact, actually, if we'll have a look at this, generally there's there's the while loop. I'm just going to copy this. Shouldn't really copy and paste because it stops you from learning. So this is going to, and I'm going to take away the gunk that we don't need at the moment. We need to include tasking. Go. So do forever, and then when we finish, we're going to run this. So if I build that, we should be building. Because it's async, we want task. Okay, .NET run. So that'll connect to the queue. Not a lot's happening here because we're just setting up the bus. This is just boilerplate stuff. I would have expected my message to come back. So what was going on here? Was I not able to connect? Broker unreachable, guest at localhost. Okay. So I use Docker for setting up Rabbit. If we have a look at the command for that, it's this here. So Docker run the host name, exposing the ports, and then I'm using the RabbitMQ with the 3. So I've got management UI. Then at the end, I just delete it. So when I've set up loads of queues and I want to tear it down, instead of having a script or calling the APIs to flush everything down, I actually just delete the Docker container and start it up again. It's incredibly efficient that way. So okay, that's up and running. So if I connect now, in a couple of seconds I'll have RabbitMQ up and running. Awesome. So the bus started, it connected to localhost using its default passwords, which I just have with the Docker container by default. Anything to quit. There we go. So we're quitting. So that's great. So I've got a bus now. What else do we need? So we need these, just these files, because these are going to be the interfaces that we're using. One day I'll figure out how to actually copy and paste without it keeping looking the way I want it. Okay, so we need some contracts. We need interfaces that allow us to submit data out. So that's the order we're going to request, and then we're going to get an order result. So we're going to get far more data back from this. Request consumer, so in order for the request to return anything, it needs to be handled. Obviously, we need some consumer that's going to listen to this response. So we're going to take this consumer and include it. Now, what I'm going to do is I'm going to include the publisher and consumer in the same app. It's just for learning, and of course in a real world environment these would be different servers. The consumer and the producer would be running on completely different systems. Clean that up. I don't like that being on a new line. I know that MassTransit does. So that's expecting an I order repository. Why? So that's going to use this I order repository to get an order. And once we've got the order, if it's null, then we didn't find it. Otherwise, we can return it. So we need this order repository. Okay, so now we're going on to adding the request. So in order to do this, we need the add request client so that MassTransit's aware of it. It's going to take that and then allow us to have dependency injection to use it. The problem that I've got is I've already started off wrong. I already started with a console app, but do you know what? That's what I want. So if I have a look through here, just having a look at a couple of examples. So there's a builder, add MassTransit. That looks interesting. Yeah, this is AutoFac dependency injection. So, nope. Okay, so this is more Microsofty way. So create a new service, then we can get the collection of services, then we can add MassTransit, and then we can configure it. Okay, yeah, and that's adding Microsoft dependency injection. So I'm going to go that route. Let's have a look at that. If I go to my README, I've got dependency injection already for other samples that I've been using and learning as I go. So let's include dependency injection in. Awesome. Because this isn't going to compile until I've got the I order repository, I'm actually going to delete this code out, I think. In fact, if I go over, if I copy this, if I go to the website, oh, sorry, got this touchpad and it's a little bit sensitive, apart from when you want it to be. There we go. So let's have a look. We're configuring the client, but if I just do a search, oh, great. So in the example, we don't have that I order repository object. So this would never work. Okie dokie. Well, because it's not here, so I'm going to delete it. In fact, I don't need a constructor at all if I'm not passing any parameters. That makes creating the order consumer easier. Let's get rid of that. Let's get rid of that. And obviously I'm going to just mess. Status code. What is status code? Ah, but it's Being an idiot. It was short-circuiting the parameters because obviously I got an order up here, so then it was just passing the values in as like a syntactical sugar. Okie dokie. So do we build? So I should have it building now. Yep. So now what we can do is we can finally put in that dependency injection. So we got a new service. Don't know why it's called collection. Generally these type of things are called service, but anyway. Let's put it at the top, shall we? I'm going to call it service. Services. And we need to include dependency injection. Awesome. Then services, add MassTransit and add the bus. Okay. Not seen that before. So I don't want to use in memory. I actually want to use the transport layer completely. So I don't want to be using in memory. I want to be using Rabbit. So add MassTransit. So let's do this. Let's see if I can remember this without wasting your time. Services, then x dot add rabbit. That's what I expected. Yeah, using rabbit. And that added a host actually. So that I think sets up all the bus and everything. So that's interesting. It's the first time I've come across that, I think. Add MassTransit, which is part of the service configuration. That creates a host like an ASP.NET host or an API host or a console hosted service. That adds a host, or I think it's iHost. And it'll start it automatically. Now, in all the previous examples that I've been working on, I've been creating the bus myself and starting it myself like a loser. And here I'm able to actually just do it in one command, which is interesting. So if I did that and drop that down, I should be able to, as part of the service, add service transition host. That's going to be part of RabbitMQ dependency injection, isn't it? So MassTransit, sorry. It doesn't exist. Really? Did I not include it in? Seems to be okay now. F12, no definition. Maybe not. So iService collection does not contain a definition for add mass transit host. You gotta love this stuff, he says. So yeah, that's the extension method that extends iService collection, and that is part of MassTransit ASP.NET Core integration. Right, so if it's an ASP.NET Core app, you can run that app, but it's not. It's a console app, and I think that'll upset the world, so I'm not going to bother. I'm going to just carry on using my bus the way I'm used to. So config, configure endpoints. All right, it's what's going on? So config, it takes then actions and configuration. It's a bit unusual that actually, because first bit's context, then configuration, configure endpoints, but that's for using in memory. What about Rabbit? So obviously a bus registration configurer. We then have actions, config. Okie config. Doesn't take two arguments, it takes. Okay. Let's take that out. Let's then add this request if I've not got it already. So I'll leave that there so we can configure consumers and producers. We then got the bus. We configure it, we start it. Let's do .NET run and build. Okay, I'll take that old extensions out because that was not right. Okay, so we're building at least .NET run. Shouldn't be a great deal of change. Great. So now what we need to do is we've got a controller. So apparently here, this is just another way of doing it. If multiple client request clients are needed, there's a generic registration method. Since no address is specified, the generic request will use a publish. So it looks like the other one uses like a send method, which has an exact client. Right, so this is now talking about autofac, which I don't want to do, but it is quite interesting. You can include that in and build it this way. which looks pretty similar, just using a builder instead of the services. Right, customizing requests. Right, we're talking about multi-request now. I've not even got an example working because there's no producer. So that's it. Get response. There's a request. Look at this. Get response. So there's a controller here, which is then going to go and run order status result. No, controller, not a consumer. Right, it's because it's tech. That is ASP.NET, like an MVC or an API call. So what we're doing here is not what we're doing on my example. So we've got a client. Right, we've got dependency injection for a client. Okay, I'm waking up now. Sorry, gang. So we need to do that. I need to be able to get an instance of that client, so I can make a call. Okay. So if I go back to code, now I've got my bus. I'm doing stuff in here. DI providers. So if I get the services and build them, any dependency injection that's been set up, which should be set up automatically, hopefully, because we're using RabbitMQ, hopefully that will set up the dependency injections. So what do we need? We need a request client of that type. So if I do provider, get required service, and that's what I want, for a client, I should now have a client. And if I run it, invar ID, and response now should be so right line response. Message dot. Let's get the status, shall we? Status text. But I need to wire up things, don't I? Do I not need to wire up the consumer? Or is that enough? No, it can't be because it's not magic. Check order status consumer. Oh, I'm in the wrong bloody place. That's configuring RabbitMQ like its host and usernames and passwords. That's not where you configure consumers. I think it's here. Config controller. controller? No. Oh, you need to set up the endpoint, don't you? Configure endpoint. Yeah. Endpoint. Obviously, I'm going to change that. Little lambda magic. E dot. No. Let's use endpoint. Here we go. Let's set that up. Now what I want to do is I want the really nice naming. So what's the name of this? It's called an empty request. So namespace and then type. Just makes it nice. So now we've got a consumer set up, got receiving endpoint, so that should create the exchange and queue. We have a send, which gets response, and we have a consumer. Let's just put something in the console right line, calling consume, just so that we know that it's definitely running. Let's do a .NET build. Make sure that I've not messed anything up. Let's run this. Let's see what we win. So we're calling the consumer, which is good. We don't seem to be getting anything back. Oh, so we got a timeout. Timeout waiting for the response. That's interesting because we got that and it knew that it needed a response. We've configured it so that it understands there's a request client there. The great thing is that it feels like the dependency injection for getting this iRequest check order status was working, and that we got this client back, and the response back that we got from here would have been order status result. So we'll get the order status and we're going to get the result back. The problem is that we didn't get a response back for this request, and it was probably like some default 30 seconds or so. If I have a look at queue, should be guest. So what have we got? So I just cleaned up the old queue messages that I had because they'll confuse things. So here we've got a temporary queue, which is probably used as the transport layer for these requests. We have the exchange, which is set up because of the consumer. And if we go into there, that's configured to connect to this queue, which is should be. So that's the exchange, that's queue. Okay. If you have a look at the queues, they're empty. So there was also a timeout from this request. So there was a request that went out, a message was created, we've got that message ID, but there was a request timeout problem. So let's have a look at the code on the website. Let's run through this. We've got the contracts. Well, they're just interfaces. We have a what's this? Yeah, we've got a consumer which check order status, and I think that's what we've got here. Check order status. Yeah, and we know that that's firing because we saw the message coming back, calling. Then we're getting the response for order status result, and that's just going to return back order status result. You know, if we took this out, this code would hopefully continue running. It's just you wouldn't get a response back. So order status response. Now there's nothing special there. Of course, this had this other service that it was dependency injecting in, which isn't in this example, so I just had to take it out. And it was going to go away in, repository, so it's probably like a database DAO service that will go away, get that object from the database and return it. So that's fine, there's nothing there. Then we're going to use MassTransit's extension dependency injection, which did we include in? We didn't, we just got this standard, but I think that's because this is ASP.NET Core. So if we look here, we've got this configure endpoints thing, which I had trouble with. Let's see what's going on. So that should be part of using RabbitMQ. Using RabbitMQ, context and config. And config dot what was it? Configure endpoints. Configure endpoints, and it got the context passed in. Let's see what we win from that. So it looks like it's going to fail because that should have returned back straight away. We called the consumer, but we're not getting that result back. So I wonder if there's a mistake. So, well, no, we're calling that consumer. So get response is calling order status result, and that's what this consumer is configured to do. Check order status, and that's what that client is doing. It's a required service for check order. So provider get required services dependency injection. We know that's working because we're making a call. So that client is making that call, and we see the consumer producing this message calling, so we know that that's working. We're awaiting it, and we should be getting a response, and at that point it's timing out. Now I wonder if we're in the right place. Yeah, we started the bus, so everything should be started. We're awaiting, so the bus is running and up and running before we get here. I wonder if we should be building the provider before running the bus. Also, really, if we're getting dependency injection, we should really be creating the bus using iBus, but that might be one step too far. No, that's not worked either because that's going to time out. Okie dokie, let's clean this up then. Should be able to take that. Let's create the bus using DI. Got a provider. Var bus controller equals provider. Get required service. Bus controller. Should be enough. So configured the endpoint there. Request the client order. I wonder if that's enough, or I need to create this request from the provider. The bus controller, sorry. So let's see what we win here. Code's a little bit cleaner this way. Response new app, awesome. So if we have a look at this, we're getting that worked just for the shadow of doubt. An hour in. Now, please remember that the vast majority of this was me trying to reverse engineer the documentation, which was clearly written as an ASP.NET API or MVC app, and I'd started already as a console app. And then a lot of this was how to configure Rabbit, how to use dependency injection to get a service, then to configure RabbitMQ, setting up an endpoint that my consumer can use, and then saying that we're going to get a request. It's going to be a request client. Then what I can do is use dependency injection to get that request client and then call it and get a response back. Now all this code will be boilerplate code. It's just nonsense. You can move it into using statements and clean it up. And then eventually you'll just have this service that you'll call, which will be some proxy class that's, just get order. And the caller of that, the developers who call that proxy won't have any understanding or any knowledge that that's happening in the background. And really, nor should they. No, they don't need to know about that stuff as a user of that library or that code base. It should be hidden away. So let's run through this. We're 48 minutes in, so I generally don't want these to go longer than an hour. So start off, we created some contracts, the request that we're going to make and the response that we're going to get back. Then we have the service collection, which allows us to fire up dependency injection, adding MassTransit and using and configuring the endpoint for our consumer. And that's going to set up the exchange, and it's going to set up the queue. Awesome. Then we're going to configure it to get a client request, which will configure an iRequest client object, and the type that we're interested in is check order status. Right, so we set the provider up for dependency injection, just build all that so that that's all up and running and all the services are being fully configured. Now we use the dependency injection to get an instance of iRequest client, which is here. Then we get the bus, and because we're using dependency injection and we're using this, we're going to get the same bus. What I think happened before is there were actually two buses set up, which kind of explains this gubbins. And we start it, and then we make a call, and all of this is all for that one line. The entire hour has been dedicated to just doing that. That goes off to a queue, gets calls a consumer, the consumer responds with the data, and we echo it out onto the screen, which is new app. So please be aware at this point, this code had no idea that that order result. It had an order that it's submitting off, but the order result that comes back will be different. So we're sending a check order status, which is why we've only just got an order ID, and then it's going to come back with a result, which comes into here, and we call it. This is just boilerplate code again for a console app, so it doesn't crash out or close instantly. I'm just waiting. Then at the end, we'll close the bus successfully. Yep. And then the consumer, this gets that request and sends it off. So here you could have a response that goes to the DAL or even delegates that to another consumer. Please go away and get this data for me. It goes to the database, the data layer comes back with that object, and here we come back with this. So new app v2. If I run that, then it's going to make that request out. It's going to come back, and we're going to have the new app v2 coming back from this response. Now, if this consumer was running in Kubernetes or wherever, God forbid you had it running on as a desktop app or as a background service, you can close that down, make changes to the code, fire it up again, and this new v2 would come back instead. And that is really, really powerful. If you've got a really big legacy application that's got lots of code, you can actually start considering which code changes the most and moving it to an architecture, moving it to this pattern so that you can create a really light, small application. Obviously, we would clean this up, but it's small, it's lightweight, easy to understand. You drop that feature out as a Dockerized container system on Kubernetes or even AWS or whatever. It runs, it does the job. Now from your code, you configure the bus, but you only need to do that once. This is just set up, this is boilerplate, and then you make the call here to get the response, and you've delegated out all of that code that used to exist in your legacy application out to a really loosely coupled microservice that allows it to be changed, unit tested, and built in isolation, which is super, super cool. Please note that if you had this code in your legacy application and it just run code, well, it's going to be instant, isn't it? It's going to be as quick as you can get it. When you start migrating this out, you've got the wire to deal with. Data has got to go across the wire, it's got to go to that service, and it's got to wait for the response. So you've got to be careful. But because you get AO8 out of the box, what you're then able to do is, clean this up. What we could do is, let's see if I can do something a bit more funky. I'm just trying to think what I could do to run this multiple times. So what I can do is I can do response A, response B, and take the AO8 off, and then task.all. Then AO8 that. And at that point, response A. There won't be a message, I don't think, because you just have the object. So what would be response A? Oh, you start getting result, don't you? Message. Timestamp. A. Response B. and so that it's got a fighting chance. If I go to the consumer, I can never remember how you sleep because it's absolutely and utterly not useful. So I think what we're going to see here is something really unusual. So although there was a sleep, it came back with the same time. Now that's not a bug. That's because I'm using the invar, and that's going to come back with the same ID. Because actually, because we're running them both at the same time, what's happening is that you're actually got the same kind of correlation. If I was to do message dot result dot message ID, although they are two completely separate messages, actually, as far as mass transit's concerned, they're not, because you're doing it as a transactional unit. So they got the same ID. If I then did response C and await that, and copy and paste that and put that in there, and the C is going to be a completely different thing. Message ID. Didn't expect that. I expected response C to come back with a different ID. Oh, it has. So actually, yeah, they are different, and they're all different. 28. So is that the same? Feels a little bit odd. I was expecting A and B to get the same ID back, and C to be a different one because it's not using the when. So A is different. They're all different, but just by this bit here. Okay. But one of the core things to think of, there is correlation between how if you task these things together, they get done and get considered to be the same thing, like as part of a correlation. However, when you do response C, it's done separately. But we can see now that if we was to do C as part of the task as well and include it as part of the when all, what's happening now is that we're going to run all three requests in one go. So it's going to take 2 seconds in total to run. 1, 2, and there we do go. All three have been done. So it didn't take 6 seconds because each one has to wait 2 seconds. This is just standard Microsoft's task parallelizing library. So async await type goodness. It's nothing new, and it's not a mass transit type thing. But it does mean that you can delegate now responsibility to multiple services. You know, if you want to get an order, add item to the warehouse, send an email, ship something out, then you can do that by just calling these tasks in parallel, but still get the individual results from each one and wait for all of them to complete. That is incredibly powerful, and there's not a great deal of stuff we have to do to get this up and running. So this is really, really cool. So I think we're hitting an hour now. I'm going to wrap it up. If I have a look down at the bottom, this is where we talk about the multiple requests, which is what I've just done. And we can configure response types. So this is the interesting bit is you can handle different response types. So at the moment we were just getting the order response. So if we look at that, that was just going to be an order status result. But what happens if we want to raise a not found or order not found? Well, we can do that by actually responding with that different type of object. So if in our consumer, if we couldn't find anything, if that doesn't exist, we can throw and respond with a order not found contract. And then in the response, we can look at what type it is. And is type of or is our type of order response. So response is it an order status or is it a order not found? And we can do stuff related to that. So unlike a lot of code where you get that exact type back, you can actually get different types back and process it accordingly, which is really cool if you have a product, but some products have got different properties. Some products in your warehouse might have size, some might have height, some might have weight, some might have other values that just aren't appropriate. So you can have the right object types and object definitions and return them back as an array, as a list, or as just a single value, and work out what the response type is and write code accordingly. And that wraps it up. We've gone through this. I apologize. I know a lot of this was getting it set up and getting it up and running, but I think that's important that I do that within these videos. In in the power videos that I'll be doing, the big workshops that I'll be doing, I'll actually be setting up a template that just allows me to do, .NET new MassTransit template, and it'll just be up and running. Where at the moment, what I want to do is actually show how to build one from start to finish. And I think that's really useful in these videos. If you got to this point in the video, then well done, um, and thank you for watching. And next week we will touch on sagas. As always, if you like it, please click that subscribe button. It helps me out a lot. Thank you.